This is a clean two-pointer string problem. We keep one pointer in each word and alternate appends until both words are exhausted. We need to merge two strings in alternating order, starting from word 1, and append any leftover characters at the end. Solve LeetCode 1768. Merge strings alternately. Example 1 ends with answer apker. The merged string will be merged as so. Word 1, ABC. Word 2, PQR merged. PBQCR. Example 2 ends with answer apks. Notice that as word 2 is longer, RS is appended to the end word 1, AB. Word 2, PQRS merged. PBQRS. The important sizing limits are 1 less or equal word 1 dot length, word 2 dot length less or equal 100. Word 1 and word 2 consist of lowercase English letters and example test cases. The invariant is simple. At each step, the merged string already contains every character before pointer I in word 1 and before pointer J in word 2. Keep one pointer in each string and add the current character whenever that pointer is still in bounds. So in practice, take word 1I, then word 2J, move each pointer after using its character, and if one string ends first, keep draining the other one. The pointers advance in lockstep, while both strings still have characters, and then the leftover tail from the longer string is appended automatically. With word 1 equals ABC and word 2 equals PQR, the merged answer becomes aptker. So the walkthrough goes in order. First take a first because word 1 starts the merge, then take P from word 2, and finally continue alternating until one pointer runs out. For the deeper version, the important thing is not more code first. It is naming the invariant that makes every local move safe. The long version should pause on the invariant or the local rule that makes the solution reliable, not just on the final code. So in practice, name the rule that stays true while scanning. Connect that rule to the pointer or state movement, and then the implementation feels natural. The code just mirrors the pointer logic. Append from word 1 if I is valid. Append from word 2 if J is valid, and keep going while either pointer still has work left. In the code, focus on two checkpoints. Watch where the answer updates inside the loop. Then notice which value is returned to finish the reasoning. Here is the full Python solution. The only real idea is the pair of pointers and the leftover character handling. In the code, focus on two checkpoints. Watch where the answer updates inside the loop. Then notice which value is returned to finish the reasoning. This is linear in the total number of characters, because each pointer only moves forward and every character is written once. Every character is appended exactly once. So in practice, time complexity. O-len word 1 plus len word 2, space complexity. O-len word 1 plus len word 2 for the output builder, and two pointers keep the control flow simple. For more LeetCode practice, follow and subscribe to the channel. This is AI and human collaboration.